My name is Tamar Gutnick. I am a neuroethologist, which is a scientist that is interested in the combination of behavior and brain in animals. When you're recording brain waves or brain activity, that basically you're recording the electricity, that is the electrical activity in the brain. And so our brains and the brains of other animals are a big aggregation of neurons, and that's organized into different areas, and areas have specific jobs, but all of them are using electricity. So what we can actually do is put an electrode, which is going to measure how electricity is moving. Octopuses are absolutely different from anything else. What is very unique about octopuses is that they have um, a lot of neurons, but most of these neurons are actually not inside their brain. They're inside the arms. And these arms, they have 8 of them. They can move in any direction. They have no bones. And on each arm, you have hundreds of little suckers. And each one of these suckers is what we would think of as a tongue and a finger. And we also know now that they can sense light. So all of this stuff is happening in hundreds of places in the octopus's body. And all of that information is somehow going into the brain. Basically, challenge number 1 is if anything is outside the octopus's body and bugging it, an arm can reach there and remove it. The arms are very, very strong, and they can reach absolutely everywhere. And if there's something there, the animal is going to take it apart. So the first challenge that we realized is that we have to implant everything inside the animal. Once it's inside the animal doesn't really mind it. It doesn't really feel it. The next challenge that we had is actually figuring out where to put it in the brain. So once we implant everything underneath the skin, we also have to get the electrodes to the brain and figure out that we can and manage to put them in the right locations. And that's a challenge because unlike working with a lot of vertebrates where we have an atlas where you can look page by page about the brain and how big this area is and how big that area is, that doesn't exist for octopuses. Now we can record the electrical activity. Now we have to figure out what this electrical activity means for the behavior of the animal, or for the way it gathers information, or for how it controls its body. So I've always been fascinated by animal behavior, and I realized that animal behavior is basically everything is controlled by a brain. I always felt that there's a lot of animals that people just are less likely to look at because there are a lot of technical problems in them, or because it's very hard to ask different animals that have different bodies and live in different environments to ask them the same questions in order to figure out what they can do. So, for instance, if you want to teach an octopus an association, you would have to approach it differently than teaching a turtle an association, or teaching a rat association, or teaching a person an association. And each one of these is a technical, each one of these is a technical challenge, but it's also a very interesting challenge because you have to think about the body of the animal and how the animal interacts with you. And all of that, underneath all of that stuff is the brain. And that's how that's what drew me into the field.